enthalpy is delta H. It's going to be products minus reactants. If we have a negative delta H, that means the reaction is exothermic, and a positive delta H means it's endothermic. So this reaction, is it endo or exothermic? You said exo, you're correct, because again we have a negative delta H for the reaction. So what this reaction is telling us, it tells us that for every 2 moles of hydrogen gas and 1 mole of oxygen gas, we're going to produce 2 moles of water vapor, and we're going to produce 483.6 kilojoules. So the negative is just telling us that the energy is going out. Another way of seeing this would be plus 483.6 kilojoules. So seeing energy as a product. So those two mean the same thing, a negative delta H or energy as a product. So on this problem, we have that same balanced equation, but we want to know how much energy will be produced if we have 20 grams of oxygen gas and excess hydrogen. So this is very similar to a stoichiometric problem, but instead of a mole to mole ratio, we can have a mole to energy ratio. So step 1 is if they give you grams, you need to convert it to moles. Once we get it to moles, then we can do our mole to energy ratio. So we have moles of oxygen and we're trying to go to energy, which in this problem is kilojoules. Our coefficient is a 1 for oxygen, and our kilojoules is 483.6. So 302 kilojoules will be produced. We also could say negative 302, but since the problem says that it'll be produced, I like to put the word produced instead of negative, since you can't have negative energy produced. So go ahead and pause the video and try these 3. Restart when you're done. So first, you should have asked yourself, well, is this endo or exo? It should have been exo since we have a negative delta H. And exothermic reactions mean that the beaker should be getting warmer because it's releasing energy. That energy is going to go to the beaker, it's going to go to the thermometer, it's going to go to the surroundings. And finally, we're looking for the enthalpy change. Remember from our specific heat video, if it asks for the enthalpy change, we need a sign on our answer. So we only have 14 grams of NaOH, and that's grams, so we need to convert that to moles. And then we have 1 mole of sodium hydroxide will produce negative 43 kilojoules. So our final answer is negative 15 kilojoules. Go ahead and pause the video and do this one on your own. This one I didn't give you the equation, but I did tell you how much kilojoules for every mole of sulfuric acid is diluted. So step 1, you should convert those grams of sulfuric acid to moles. And then our conversion is for every 1 mole, we'll have 75.3 kilojoules. And we're trying to find out how much heat would be released, because again, it's releasing energy, and we want 2 sig figs, so 6.8 kilojoules. So this one, we have methane. Methane is CH4. So go ahead and pause the video and try this one on your own. Restart when you're done. So similar to our last problem, step 1, convert your grams to moles. And then we have 890 kilojoules released when 1 mole is burned. So for every 1 mole of CH4, we have 890 kilojoules. And it says calculate the change in enthalpy. So it didn't say that energy was being absorbed or released, so we need a sign. And we're burning something, so if we're burning, it should be exothermic. So negative 320 kilojoules. So again, notice the difference. This one says change in enthalpy. It doesn't say if energy is being absorbed or released. It just says calculate the change. While the previous one said predict how much heat would be released. It didn't ask for enthalpy, and it specifically said the heat was released. So another type of problem that you could see is where you're going to first have to calculate that delta H. So to calculate the delta H, we can use the enthalpy of formations from the back of your notes and use the equation delta H is equal to the sum of my products minus the sum of the delta H of formation of reactants. So first we have aluminum solid. So if we look on here, we're going to be looking at the delta H column. We'll use delta G and S later in the year, but right now we're looking at only the H. And aluminum solid is a 0. So bromine's normally a liquid, so it's 0, while if it was a gas, then it would be a different value. So we have our aluminum is 0, and then we have aluminum oxide is going to be negative 1676. When looking at the chart, also make sure you're paying close attention to the states of matter. Two that people mess up a lot are H2O liquid and H2O gas. Notice they are different values, so you'd want to make sure that you're choosing the correct one. So go ahead and find all the values for each of these. So again, we just saw aluminum was 0 and aluminum oxide was negative 1676. So go ahead and find iron and iron 2 oxide. Restart when you're done. So those are our values. So delta H is equal to products. So I'm going to do open bracket negative 1676 plus 2 times 0. Technically, I don't need to do the 2 times 0, but if it was something other than 0, I would need to make sure that I'm including that. So these are my products minus all of my reactants. So again, 2 times 0 plus negative 825.5. So these are my reactants. The main place people mess up is just the algebra. They get this far and then they mess up plugging it in. So I highly recommend breaking up the problem and doing all of my products. So doing this, get your answer, and then do this, get your answer. So delta H is equal to negative 1676 minus negative 825.5. So now plugging that in the calculator, my delta H is negative 850.5 kilojoules per mole. And that means this is exothermic. Once I get this delta H is what we were previously seeing up here. I could convert my aluminum, grams of aluminum, to energy, or grams of iron 3 oxide to energy. So for this one, go ahead and pause the video, find the values for each of those from the back of your notes. Restart when you have all the values. So first, I'm going to do my products. When I have more than one, I need to multiply by the coefficient. So I only have 1 nitrogen, but I have 4 waters, so 4 times negative 241.826. So again, these are my products minus all of my reactants. Then I'm going to simplify. And again, I get a negative delta H, so again, this one was exothermic. On here, potassium carbonate wasn't on your chart, so I went ahead and gave you that one, but go ahead and fill out these other three. Restart when you have those. Okay, these are your values, so go ahead and pause the video and calculate your delta H of the reaction at this point. Restart when you're done. So you should have got a negative 148.926 kilojoules per mole. So again, this one was also exothermic.